Hello, this video continues the series on dynamic programming. In this particular video, we're going to talk about repeated work and how that leads us to the actual topic of dynamic programming. So in the last video, we talked about how searching through a space of solutions can be viewed as descending a tree. My tree here is binary. It does not have to be binary. The branching factors can vary at every point, and different problems will have different branching factors. But we talked about how we can go through this tree in different ways. The key to dynamic programming is that in a lot of these trees, there's repeated work. So for example, some sub-branch over here might be identical to another sub-branch over here, and the idea is that we don't want to have to duplicate that work. Indeed, you've probably seen this type of duplication. One of the first problems you've ever seen in when you started talking about recursion was Fibonacci numbers. And so Fibonacci numbers, you had a see if I call the 6th Fibonacci number. Each Fibonacci number was defined as the sum of the two previous Fibonacci numbers. And so the value at 6 called itself with 5, which called itself with 4, which called itself with 3, which called itself with 2, which called itself with 1. Okay, and then it called itself again with 1, and it took that sum and it passed it up to the 3, and the 3 then called with 1 again, and we can go ahead and link all of these things together. Okay. And then the 4, after calling itself with after calling with 3, then calls with 2. Well, and this is where the so drawing all the arrows, it's easier on a whiteboard than on a computer. But on the computer, I can actually do this and demonstrate very clearly that we just repeated some work, because this sub-branch for 2 over here is identical to the sub-branch for 2 over here. The 5, after the call with the 4, winds up calling with 3. So we can take that entire sub-branch with the 3 and put it over there. And then, of course, okay, I'm going to have to get rid of this tree to make room for finishing off the Fibonacci. After the 6 is done calling with 5, it calls with 4, and so we have to copy that entire sub-branch there. Whoops. Control-Z. Paste. Make sure I grab something here. Okay. And that looks about right. And we connect that to there. Let's go ahead and drag our 6 over a bit so it's kind of centered. Okay. So this was a tree view of calculating the 6th Fibonacci number, and clearly there is a lot of work that is being duplicated in here, and there is no reason to duplicate this work. The approach of dynamic programming is, instead of duplicating the work, what we want to do is we want to store it inside of an array, a table, that we can then look values up, so that instead of doing the same thing over and over again, we just look up the values. Now, of course, when you're doing Fibonacci numbers, all you would have to do is keep the last 2 numbers. If you take kind of a pure dynamic programming approach, you actually store all of the values, and instead of, when we do this recursively, we start at the top and we go down. In dynamic programming, you start at the bottom and you fill in the values on the way up. So we would fill in an array starting with the two ones at the bottom, and then when we would look up those two values and add them together to get the 2. And then we would look up these two values and add them together to get the 3, and then a 5, and then an 8, and a 13, 21, etc. Okay. And so whatever number it is that we wanted to look up, we would build an array of that size, and we would fill in the values going from the bottom up. And this would be more of a dynamic programming approach to solving this. Now, dynamic programming is generally applied in areas where we're doing optimization. And so in the next video, I'll come back and I'll tell you how, specifically what types of optimization problems we can solve using dynamic programming, and then we'll look at our first example.